All right, so looking at the review, one thing you probably noticed about the review is it really is a review, not just of Unit H, but there was some SOHCAHTOA and other stuff in here too. So for the most part, people have been doing fairly well with the concepts of quadrilaterals. And probably you found from problems 13 through, 13 and on, you probably found those problems pretty straightforward. And where probably got you a little bit tripped up would be things like 1 through 12. We had to solve triangles and go back and look at that sort of thing again. So 3 and 4 were Pythagorean theorem. 5 through 8 are the special triangles. So let's just very quickly review those special triangles. And why are we putting this on here? As some people are going, well, seriously, that's not even this unit. Why are we doing it? Because every unit has review questions. And this is the kind of thing that's going to keep coming up again and again and again, understanding these special triangles. So remember, on the 45, 45, 90, we had 2 legs the same, and this is times the square root of 2. The 30, 60, 90, the long leg is the n root 3, and this is the 2n, and again, that's a 30, 60, 90. And this is a 45, 45, 90. So setting those up, like number 5 was pretty easy because it was 5 root 2, so the sides are 5 and 5. And for 6, it went 4, 4, 4 root 2. 7 was a little tricky because they gave you the hypotenuse is 4. But if this is 4, how long is the short side? And then 2 root 3. And again, 8, they gave you a 6 root 3 here, meaning this side was, and this side has to be 12. Yeah. Sine, cosine, tangent were not appropriate for 5 through 8 because those are special triangles. And we don't use sine, cosine, tangent with those. Okay. Sometimes, but you wouldn't get 5 root 2 exactly. You'd get a decimal approximation of that, and we wouldn't want that. You'd want to be exact. So when you have a special triangle, you do need to use special triangles. Yeah. Okay. Did you maybe? That just let's not worry about it at the moment, okay? 9 and 10 we did need to use SOHCAHTOA. It's been a little while since we've done that, but again, just reviewing it very quickly. We had 13, 40 degrees, and x. And again, just reviewing. This is my angle, so this is where my little person stands. 13 is the opposite side. X is the hypotenuse. And we have SOHCAHTOA. Opposite hypotenuse is sine. So sine of 40 is the opposite over the hypotenuse. And again, when the x is in the denominator, we just swap. 13 divided by sine 40. And when we put that in, we get our solution, which I actually don't have in front of me right now, but about 20.2 for that distance. And 10 was similar. Except 10 we used actually tangent. Tangent 53 equals x over 20 is your equation. Of course, you have the solutions, so I'll tell you what those are. 11 and 12 are using the inverse functions again. And if you need the chart, remember on the test tomorrow, you ask for a chart if you need one. We had 32 and 42. I'd ask for x as my angle right there. So again, that's my perspective. And I set up my relationship. This is the adjacent, that's hypotenuse. So it's cosine of x equals 32 out of 42. And we turn that into a decimal. 32 divided by 42. 0.7619. Now, we do not take the cosine of 0.7619. That's the value of cosine. We need to find the angle that gives us that value. We take the cosine of an angle. If we know the value of cosine, we can work backwards to find the angle using the chart or the cosine inverse function on our calculator. I can do second function cosine of the 0.7619, and I'll get 40.4 degrees approximately, which is where we're at. So the inverse function helps me, but the regular function does not. And for 12, if you set it up, it should have been the sine inverse of x equals 3 over 11. That's the formula you needed. So again, that review stuff is going to appear on the unit test again, because solving triangles is just foundational to everything that we're doing. So that will show up there again. It's not the biggest part of the test, but there are some, 20% of the points there. So Pythagorean theorem, SOHCAHTOA, special triangles, that's all still in play. It's not going away. How about for the 13 through the rest of it? Any questions specifically there that you want to go over? If not, I've got just some more general example problems to review. And then tomorrow is going to be our unit test. Remembering that these unit tests are the big deal that we can only retake once. And that also kind of signifies the end of our retake period for Unit G. I'll allow you to continue to retake things basically through the end of the week, but that's it. End of this week, anything from Unit G needs to be done. Let's just take a look at this. Find the value of x given that the shape is a parallelogram. What I've got here is all sorts of different things we can do, and all different ways we can set up equations. So let's just start here. What would the equation look like in that case? Okay, 3x plus 10 equals 60. Because opposite sides are congruent. Okay, how about if I do 60 here and 5x here? What would the equation look like now? 60 equals 5xy. Which property of a parallelogram are we working with there? Diagonals bisect each other. Okay. What if I do here? Sure, that'd be 5x plus 60 equals what? 180, because consecutive angles are supplementary. Okay. How about now? What's that equation going to look like? Because which are we showing here? Opposite angles congruent. Okay? So again, just different ways of setting up equations. And I know you can solve those once they're set up, but that's why it's really important that you show how they're set up and understand those properties of parallelograms. Remember, these properties apply to all parallelograms, whether rectangles, rhombuses, squares, or just regular old parallelograms. They do not apply to trapezoids, kites, or other shapes like that. If you're given verbal directions, your first step would be to draw the rhombus. Given PQRT as a rhombus, are the following always, sometimes, or never true? Don't try to answer the questions without a picture. Your rhombus does not have to be perfect. Mine most certainly is not. But PQRT, notice I go consecutive around. I could have started gone PQRT. That would have been fine. It's not going to change my answers. What I don't want to do when I'm naming it is go PQRT. We always go in the order one way around the shape. And it also tells me then that PR and QT are diagonals of that rhombus. So now, always, sometimes, or never true. PQ is equals RT. Always, sometimes, or never. Always. Okay? PR equals QT. Always. Diagonals are congruent in a rhombus. Excuse me for a second. I shall do so. All right. I'm talking about something. Trouble again. Actually, it was about you, Milton. You wanted to know. This guy is a pastor from church. I want to talk about you. Heard I had a particularly disturbed young lady in class, and wanted to see what he could do for you. Okay. All right, so PR and QT, are the diagonals always congruent in a rhombus? No. Are they sometimes congruent when the rhombus is a square? So that's a sometimes. PQ perpendicular to RT. PQ and RT perpendicular. Always, sometimes, or never? Never. Why not? Yeah, they got to be parallel. They can't be perpendicular. They're opposite sides. Angle P congruent to angle R. Always, yes. Angle P congruent to angle Q. Sometimes if it's a square, but not always. So again, understanding the properties of a shape. That's really what a lot of this comes down to. What are the properties of a parallelogram, or in this case, a rhombus? Find the values of x, y, and z. These aren't too bad. It is an isosceles trapezoid, as you can tell. So if this angle down here is 70, what's angle y got to be? 70. How about angle z? 110, because it has to be supplementary. Now, before I get into a fancy formula, let's just think logically. What is that going, if I've got the base on top is 15, the base on bottom is 25, that's going to have to be 20, right? Yeah. So 2x has to equal 20, so x has to be 10. Okay? So again, trapezoid's not that tough, and mid-segment's not that hard. Give the most specific name, not necessarily drawn to scale. What is this first shape? It is a rhombus. Okay? How about this one down here? It's a tricky one. Close, not quite. No one's guessed it yet. Let's think about this. The diagonals clearly are bisecting each other, right? Okay? This point is the midpoint of both diagonals. That means it is some type of a parallelogram. And the diagonals are congruent, so that's a rectangle. Okay? That is a rectangle. So, again, looking at the facts and using the facts to make a deduction about what kind of shape it is. We got to know our rules. That's the big trick. Given ABCD is a kite, angle ADB is 40, angle ABC is 125, find the measure of angle BCA. So let's mark that in. ADB is 40 degrees. ABC is 125. Okay, so the whole angle there is 125. Find the measure of angle BCA. Wants this angle right here. All right. Well, this is going to require a little detective work. If ADB is 40, now let's think about this for a second. Consecutive sides in the triangle have to be congruent. So if I just look at the triangle up here, these two sides have to be congruent because it's a kite, right? So if these two sides are congruent, what about these two angles here? They have to be congruent, so that's a 40 degrees also. We know the diagonals are perpendicular, so that's a right angle. Now this is 40 and this is 125. How many degrees are left here? 85 degrees. So if this is 90 and this is 85, this has to be, careful. If I just look at just this triangle, if this is 90 and this is 85, how many degrees are left for that angle? 5 little degrees. Okay? So here we see a problem that involves things about isosceles triangles and kites and right triangles. They all go together. I mean, honestly, this is one of the things that makes the final exam in here kind of not that tough in a lot of ways, because we keep reusing all the stuff we've learned the year before. It's not like we learn, it's not like in English where maybe you learned about some book in the first quarter, and you don't even talk about it again until the exam time comes. You got to recall things from all the way back then. We keep reusing things, so that kind of helps reinforce a lot of those lessons. You get to see them again and again and again. What type of shape is ABCD? My goodness, how many times have we seen this? Again, without the evidence, your answer won't be accepted. So you have to show the evidence. I think I've made that pretty abundantly clear at this point, that just having the right shape name really doesn't get you anything. You have to prove it. So you have to plot our points. Now, some of you are still having problems plotting points. Not many, but 0, 3 is on the y-axis right there. There's A. B is at 5, 1. C is at 3, negative 4. And D is at negative 2, negative 2. Okay. Now, Jake thinks it's a rhombus. How can we prove that? How could I prove that it's a rhombus? Okay, midpoint formula. What did I find the midpoint of? The midpoint of the midpoint. Yes, that makes sense. No, it doesn't. Makes no sense whatsoever. Ignore her completely. How could I prove what kind of shape this is? Okay, I've got a picture. I've got a pretty good idea what kind of shape it might be. It might be a rhombus. It might be a square. It might just be a plain old parallelogram. I don't know. We got to check it out. What do you think we do, Jared? Distance formula for the sides? Yeah, I could measure all 4 sides, couldn't I? That might be a lot of work, but I could certainly do it. So let's go ahead and do that. AB So, Jake, stop running the mouse. So 0 minus 5, 3 minus 1. That's negative 5 squared root of 25. 3 minus 1 is 2, so that's 4 square root of 29. BC. 5 minus 3, 1 minus negative 4. That's 2 squared plus 5 squared. So square root of 29. By the way, when you're doing this, don't lose your square root symbol. Some of you are doing that and you're saying the length is 29, and that's the square root of 29. 29 is not correct. It is the square root of 29. CD, 3 minus negative 2, or 3 plus 2 squared. Negative 4 minus negative 2, or plus negative 4 plus 2 squared. So that's 5 squared plus 2 squared again, which is going to be square root of 29. And dA, negative 2 minus 0, and negative 2 minus 3, square root of 2 squared plus negative 5 squared, and square root of 29 again. So we know all four sides are congruent. Does that prove it's a rhombus? Yes, it does. Does it prove whether or not it's a square? No. We now know it's a rhombus because all four sides are congruent. We don't know whether or not it's a square. So I have to do a couple more measurements. The easiest thing to check at this point, and you got a couple choices. I could see if the diagonals are congruent. That would make it a rhombus and a rectangle, and therefore a square. Or I could check the slopes of two sides to see if they're perpendicular. So let's check the slope of AB. The slope of AB would be 3 minus 1 over 0 minus 5, or 2 over negative 5. Slope of BC, 1 minus negative 4, 1 plus 4, over 5 minus 3 is 5 halves. Aha, these sides are perpendicular. It's a square. Okay? The correct answer is square. Rhombus is not the correct answer. No. It's a square. Most specific answer. Rhombus is incorrect. Close line counts, horseshoe, hand grenades. All right. So we aren't going to worry about that. So anyway, again, folks, you need to be prepared. Know your facts. Know a little bit of that Pythagorean theorem. Go back and review that. Know the differences with these things here. That clock's a little bit fast since it's been reset. I'm going to have to reset that back a little bit. It's about 3 minutes fast. It's, yeah, it's 11:20. So, your homework tonight, there is no homework assignment tonight other than to study for the exam, or study for the test. Jake, you didn't even do the tests. Why do you care about the homework?